Okay, these look really scary, but the trick here is to just write all of the terms as just some coefficient times x to some power. So I'm going to start by converting all of the x terms, or all of the x parts of each term, into their respective powers. So this first term is going to be 6x to the fourth. The square root of x can be written as x to the 1/2. Plus the 8's going to stay there. I have x squared on the bottom. I can write that as x to the -2, right? Negative exponents put me in the denominator. And I have the square root of x in the denominator, so that's x to the -1/2. So now I have 6 times this. I can, when I'm multiplying bases, common bases, I can add the exponents. So this is 6x to the 4 plus 1/2. That's going to be what, 9/2? 8/2 plus 1/2 plus 8. I have x to the -2.5, which is x to the -5/2. Now it's just a matter of applying the power rule. So this is still f of x. Let's rewrite this. Now I can say, all right, well, the derivative is just bring down the power. 6 times 9/2. That's 54 halves. 6 times 9/2. X to the 9/2 minus 1. Well, 9/2 minus 2/2 is 7/2. The next term is going to be 8. Bring down the -5/2. 8 times -5/2 is -40 halves. X to the -5/2 minus 1. -5/2 minus 2/2 is -7/2. So really the only thing we can do from here is, I don't think they want you to put this like back in the denominator. I think you can maybe leave this the way it is. This is going to be f prime of, this is 54 over 2 is 27. X to the 7/2 minus 40 divided by 2 is 20. X to the -7/2. Let's see. I don't know how they want you to write the answer. Okay, they want the 7/2 on the bottom. So they do want you to move this back to the bottom. Maybe they'll accept this. I don't know. Try it. If they don't, then I guess they want you to write each term with positive exponents.